Good day, everyone. Welcome to today's session on production-ready Python Serverless API. Before we jump in, let me introduce myself. I'm Raphael Jambalos. You can call me Jambi. I'm currently the team lead of the Cloud Native Development Team here in eCloud Valley, Philippines. I currently have 4 AWS certification, and I'm also active here in the community of AWS in the Philippines. I'm also AWS Partner Network Ambassador and a community builder, helping organize meetups here in the Philippines. And I'm also hanging out in dev.to. So if you're active in that blogging platform, I'd love to hear from you. And I also have a companion blog post for this talk. All right, so without further ado, let's get started. So our objective for today is helping you have production-ready Python serverless applications. And to do that, there's only 3 things you have to think about. First is tools. Now, how do we maximize the use of AWS services to reduce the code we're going to write and reduce the services that we're going to maintain? Second is the deployment. We're going to discuss the different ways we can deploy code in AWS Lambda. And third is the software architecture, how we organize our Python code to fit the cloud native paradigm. All right, let's get started. So first is the tools of the trade. When you're deploying serverless application, you're usually mostly in the cloud already, right? So you want to be able to maximize using the cloud services that's available to you and minimize what you're going to code. So how are we going to do that? First tool that we're going to use is Serverless Framework. It's very powerful in that it's a powerful deployment framework for serverless applications. It's also applicable for AWS, Azure, and GCP. But for this session, we'll only focus on AWS. As a deployment framework, it has 2 uses. First is provisioning serverless infrastructure. What you see in the right hand side, we have 33 lines of code to deploy a basic two endpoint web API. Under the hood, Serverless Framework converts this short syntax into CloudFormation. Now, CloudFormation code of this may be like 150 lines. So you can see there's a lot going under the hood. What Serverless Framework does is it places sensible defaults, so you don't have to think about every single thing that you have to deploy. Your API just works well by default. Then the second responsibility of Serverless Framework is packaging and deploying Python code. So you don't have to think about putting it into zip files and uploading it to Lambda. If you have all these dependencies, Serverless Framework will do that for you. So you can also, this talk is also applicable for AWS SAM. If you're using that framework, it's also applicable. All right, so other tools that we're going to use, and I suggest you maximize using. First is Lambda. That's where we deploy our code. Our pay-as-you-go compute engine. We just push our code in Lambda and trust that the infrastructure will be there to run the code for us. Second is API Gateway. Essentially, it acts as a gateway for our API calls, API requests. And it also provides other features that's lesser known, like request validation, simple transformations via mapping templates, throttling, metering. A lot of these things API Gateway can do. Then finally, we have DynamoDB. It's a NoSQL database. When you have Lambda applications, they can scale into thousands in just a single second. So we highly suggest that instead of using RDS or instead of using relational databases, we suggest you use NoSQL databases, which will be able to fully capture the scale that Lambda is able to do. If it can scale to 10,000 requests per second, then so does DynamoDB. Then finally, Cognito. It's a user authentication service that's a favorite for cloud native developers in AWS. So you don't have to think about password protection, encryption. You just use Cognito and then you're good to go. Other tools, let's go just through this very quickly. First is the event-based triggers. When you're doing serverless applications, you don't want to have a cron job every hour. You want to be able to react as events come in or events get triggered in your application. So for SQSQ, we can queue up the tasks as it comes in. If you have a user, for example, your system A wants to convert files, it can just queue it in a queue, and then system B will process the file process the file one by one for file conversion. Then next is event bridge. Event bridge is like a trigger for Lambda events, AWS events, events inside your AWS account, or events inside like third-party services or services in your system. No, so you can use event bridge for that. Then S3, no, you can also configure S3 when you upload something. You can trigger Lambda in order to process that file. Usually for file conversion, if you upload an image, like high-res image of my picture right now, you want to convert it into a thumbnail, a large wallpaper. No, you use the S3 trigger. No, we also use ECS, EKS, no, to process jobs longer than 15 minutes. No, because Lambda has a limit of 15 minutes. So if you want to have a job longer than that, then you use ECS or EKS. And finally, no, we use a lot of tools, no, in AWS. No, I suggest you get familiar with all of these tools, as they will make your life really easier in the cloud, no, in helping you get your app ready for production. So SNS, no, you can send simple notifications. Like for example, if you have a ticket service and you're running out of tickets to give, no, maybe the admin has to manually intervene, no, and refill the tickets. So you use SNS to just send short messages. SES when you want to send newsletters, that formatted by HTML and CSS. Parameter store if you want to store credentials, and secrets manager. And finally, the monitoring piece. CloudWatch stores logs and metrics about each Lambda function and the API gateway. So it's really good for debugging and debugging at scale. And finally, this is the last one, is X-Ray, which is for the distributed app tracing. So a little sidebar on X-Ray. It's really an excellent tool. It's underrated. Not a lot of people use that. But if you're using microservices and you have a login function that calls maybe 2 or 3 other services, then it's hard to debug or troubleshoot across 3 services. So it's better use X-Ray so you get a view as your request travels from first system, then to second system, then third system. You'll get the view of what causes maybe the reduction, the slowness in the performance, or maybe where the error is. So X-Ray really makes it visible to you. Actually has pretty diagrams that I won't discuss in this talk, but you can also catch it as it's my topic in another conference in AWS Summit 2020 happening this month. All right. So yeah, at this juncture, do you have any questions? We can give you time to type if you have any questions. Joseph?
Looks like none at the moment. I'll let you know though.
Thank you. So yeah, we're going to have another breakpoint in the middle. So if you have any questions, feel free to type it in. So yeah, getting into the meat of the presentation. So yeah, now next is the deployment architecture. How we deploy our code in Lambda matters a lot in terms of performance and maintainability. So yeah, let's get to it. First is the Lambda monolith, or something called Lambdalith. Sorry, I apologize for the background sound. It's currently raining here in Manila. So yeah, the first pattern is called the Lambdalith or the Lambda monolith. So Lambda monoliths are for doing lift and shift of web applications made with MVC frameworks like Laravel or Django. How this is done is you have a library that allows you to port your application to Lambda. So for Laravel, that's something called ref. You can also use Lambda's custom runtime if you want to push your MVC app as an image, which is the best practice, instead of using ref. Then the pros of this, of course, is it allows you to lift and shift with minimal effort your MVC applications to Lambda. Of course, the cons of this is that your MVC application is probably not made to be cloud native, so it's usually large in deployment. This means that the performance of Lambda will degrade. So it means slower response times because maybe your whole e-commerce application is like 700 MB. So Lambda has to have that enough computing power that will slow down your application. Another con here is that we're not maximizing API gateway as a router, because we're just routing everything to one single Lambda function, and it does all the work for us. So that's the cons of this approach. But again, depends on where you are in your journey. If you just have a one MVC app that you want to lift and shift, this is the way to go. So yeah. Next is a functional monolith. So the key difference here between Lambdalith and the API gateway, the Lambdalith and this functional monolith is that the API gateway does the routing for us. In that, because of that, you are forced by necessity to use a deployment framework for serverless. Something like AWS SAM or serverless framework. At least you're in the right path. But as with Lambdalith, you're still dealing with monoliths. And that's not the best way to deploy still in Lambda. Because you see, Lambda's ethos is having just one function, do one thing very well. But yeah, despite that, there's still some use cases for this, and I'll cover it. So the use cases for this is if you have a simple application that you want to deploy, you can just opt for a functional monolith. If you're like piloting serverless in your company, you have like 20 Laravel devs, and you want them to learn serverless. If you don't want them to get overwhelmed all at once with everything they have to know, perhaps you can have a small project in functional monolith first, or POC, have them POC in functional monolith, then upgrade them later to the next functional microservice format. The next pro of this is that it's easy to deploy and automate deployments via CI/CD. So yeah, because it's a monolith, it's easy to deploy. Yeah, just one component you deploy. And the cons of this is that it holds a lot of code, and this can slow down the performance of your Lambda functions. So you can imagine this one, this login function, actually holds the code for the tickets, even if it doesn't need that really. So that's how monoliths work. So you have the login Lambda function, holding code for tickets, holding code for maybe orders module, even if it will never visit that. So next we come to the recommended best practice, which is the functional microservices. This is the best practice in deploying serverless applications. Essentially, everything is in a single repository, and you divide your application into services. So in this example, we have the user module, user service. So we have like the folder users / and then we have the ticket / which is the ticket service here. And then we have separate serverless.yaml for each, meaning separate deployment for each service. So with that, the good thing with that is the code is isolated, it's smaller. For the tickets service, it only holds the code that the ticket service needs. And it doesn't hold the code for the user authentication. So it's actually more compact and hence more performant. So,
hey, Jambi, do you mind if I interrupt real quick?
Yeah.
Can you try turning off your video? We're getting a little bit of latency.
All right.
Thank you, sir.
Yeah, you can see.
Awesome, thank you.
The voice is still okay?
Yep, we got you.
Thank you. Apologies, it's raining here. It usually happens in Manila.
No problem.
So yeah, going back to functional microservices. So the pros with this is that you keep your deployments intact and small and focused. Hence your services or your Lambda function are more performant. Like it has better performance, it responds better, like it has faster response time. It's easier to troubleshoot because the code is smaller. And actually there's more fault tolerance because the code is isolated in the deployment level. Actually, the only cons of this, or the two cons of this, is that sharing code can be quite a pain. So if you have a common code between the user services and the ticket services, you would have to find a way to import that code, and it's more complicated. It's more complicated to monitor. For example, you have a JWT token helper for both ticket and user. So what happens is that if you update the user service, you upgrade it to V2 of the JWT token helper. Since the deployment is separate for the ticket service, when you upload the user service or you deploy the user service, both works. But maybe two weeks from now, when an intern updates the ticket service, to have it maybe to have it fix or to deploy an event, you will find that suddenly you're not able to create new tickets because the JWT token is updated. So that's the hassle of sharing code between services, because it doesn't error right away. So you have to deploy that shared code. So you have to find ways around sharing code and making sure every single module that uses that shared code is tested. And that's a little bit more difficult to do with functional microservices. But it's worth it. If you do the right approach, you'll be able to go around that hurdle. And finally, creating CI/CD deployments is a little bit more difficult, because you have to know which service actually did the change. All right. So yeah, next is when do we break off our repository? So just three things. Actually, this is a bit controversial, in the serverless community. So when do you break off a single repository? But here are my simple three guidelines. So first is the team. If you have independent teams working separately, then you can definitely break it off. So it's easier to manage. If you have different end users for different groups of services, so for example, for blogs, products, and checkout, you have the consumers, and for rider app, warehouse app, and then dispatcher app, you have the warehouse staff. You can separate it according to that. So that code isolation will make sure that consumers buying goods never accidentally get access to confidential warehouse data that they may not need to know. And finally, third is data isolation. This is where you want your data to be accessible only in the context of the APIs that is built around that data. This is very true for inventory. So you want to be able to access inventory only through the context of the API, because perhaps there are some rules associated with it. So yeah, so just three simple rules for breaking off the separate repository. So just a sample structure, just to illuminate this concept better. So we have a back system office and a storefront office, storefront service. Now for the storefront service, the end user is actually the consumer, those buying groceries. And the back office, the consumer of this, or the end user, is people in the warehouse fulfilling those orders. So that's actually one criteria already. Then you can separate your team, back office dev team, storefront dev team. And finally, if your data, you don't want to share data in between those services, you can also do that. So yeah, that's it for deployment architecture. So we discussed the three patterns, and then we discussed when to separate it to a separate repository. So yeah, if you have any questions, let me know. It's raining hard here in the Philippines, so am I still being heard, Joseph? Being clearly?
Yeah, we can still hear you.
Yeah, apologies for not being able to show the video. The internet got spotty when it rained really hard. All right. Do you have any questions at this juncture? Joseph?
None yet. We can give them a few seconds.
All right. So yeah, we also have a face-to-face session after this, so you can ask your questions on that session.
None yet. You can probably keep going. I can let you know.
All right. So now we discussed the software architecture, aka why we need another server, why we need like an MVC-like framework on top of serverless framework. So serverless framework, it's a powerful deployment framework. It lets you build fully fledged serverless applications with just a few lines of code. But in terms of software architecture, it's similar to Flask or Lumen, in that it is a micro framework. When you start learning serverless framework, the only thing you need to know is you have to point your serverless.yaml into the handler function, in order for your code to run. That's it. Anything after that, how you arrange your Python code, it's entirely up to you. But I think it puts a lot of pressure to developers to get it right, the first time. It also assumes that they have enough knowledge to know what the best practices are, which typically they don't. Typically we don't know everything, all the best practices all at once. So I think this is where an MVC-like framework will really help. It will help the developers use best practices by default. Pretty much how devs are forced to use the MVC style when writing Django applications. They're just limited by the structure. They're disciplined by the structure. So I think especially for helping others, helping serverless framework have more wider adoption, I think an MVC-like framework is really needed for this. For which we suggest a kind of pattern. We don't want MVC anymore simply because it's outdated. It still has views, which we delegate already to front-end frameworks like React.js or Vue.js. So we introduced the Handler-Model-Gateway pattern, HMG. We haven't built HMG as a framework, but this is what we're enforcing as a convention on our team, and I like to share them with you, so you'll be able to use it as well. Or perhaps if you have the time, you'll be able to build frameworks for this to make it easier for everyone to build serverless applications in Python. Yeah, just 3 things. We have gateways, model, and handler. Now for gateways, it's like serverless application is like meant to interact with external applications, right? So because we want our Lambda function as a simple and single responsibility as possible, we want to delegate other functionality to other services. For example, we have a checkout service. Now, if we're creating payments for that, we contact the payment service. If we're creating packages for that, we contact the warehouse service. So there's a lot of communication between APIs, and we want to capture that using gateways. So as much as possible, we want to isolate the implements. How do you call DynamoDB? We want to wrap it in gateways, so it's cleaner when you approach the model, where the model holds the business logic of your applications. In ECV, we adhere to OOP style, where models represent real-world objects. One of the things that continuously comes up with models is that the model files tend to be large. So with large model files, maybe 3,000 lines of product.py. So code tend to be super messy when that happens. So for that, we suggest fixes for the abilities pattern and the strategies pattern. We'll see that in a bit. You also have the handler. Handler is just the entry point essentially for your serverless application or Lambda. It's where you point, essentially where you point serverless.yaml to. Its responsibility is to decode and transform the request to a format your models will understand. All right, so yeah, let's proceed. So yeah, we'll just tackle the code one by one. We want to be able to see what kind of code that we have. So first, we tackle the handlers. Handlers store both the handler function and the handler class. So the handler function, as you see here, this is where Lambda directs the request. And then we call a handler class, which does the logic for us. Handlers is very similar to controllers. So you just use the handlers for that. So what happens with that? The responsibility of handler is that it extracts and reads the request. So you can send it to the business logic part or the model part, and you can extract the response that you need from the models and be able to send it back to our end users. For example, get product ID, you want to be able to send back information about the product as specified by the ID. Maybe the customer is browsing Amazon.com and he saw a cute wireless keyboard. If he clicks that, you send the ID, then you send information about the wireless keyboard. So that's the responsibility of the handler, ensuring that you can return a response. Then we have helpers. Inside this helper, the response constructor helper, we add the code that's repeated between requests. So in this example, we have the success JSON function that generates the API response required by API gateway. So this is used by all endpoints in my application. So therefore, it's a good candidate of being a helper. No, we don't want to repeat this every time we're sending a successful JSON request. So that's why we have helpers. But we don't want to abuse the helpers though. No? The tendency with helpers is suddenly your developers are making helper classes. No? When they create helper classes, their logic tends to stay in helpers instead of being in an OOP design. So be disciplined in your code review process. Do not allow business logic to end up in helpers. No, don't be like us. We have like a library of helpers full of business logic. No, very hard to maintain. So yeah, if you think code is too crammed in the model, no, don't use helpers still. No, we have fixes for you in the next few slides. All right, so yeah, now let's tackle the models. No, like in the MVC framework, no, models contain the business logic of your application. It's the best way to organize model files. To think of them as like real-world objects that represent your data entities. No? Make sure these objects are nouns. No, they're not verbs. No? Don't make gerunds, no, or noun verbs. No? Some of my colleagues get away with creating model classes like order constructor or product search, no? Or product search engine. No, they're making the verb search into a noun. No, so don't do that. No, just stick to what really is the data entity. No, for example, product. Just stick to product. No need to make it into a product search. There's actually a fix for that. You'll see later on, no, why we don't need to do that. No, if you see a verb inside the title, you're probably doing it wrong. No, so don't do that. So for an e-commerce application, no, these objects are like products, orders, collections, and articles. No. After that, think of the actions that these objects need to do. No. So for the object product, as we see here in the screen, it needs to it needs to serialize. It needs to serialize the object itself. So we have two types of code, no, or logic inside the model. We have logic for the instance methods and the class methods. What you see now, the find, that's a class method. No? So it's when do you use class method? It's actually when you have code related to product, but it's not really acting on a specific product object. No? Probably you want to use that code to find the specific product. Now, finding the product is not acting on the product object itself, no, but it's related to product. No? So you just put it as a class method. If it's related to the product object itself, now, for example, product that open package, no, or product that get price, no, that's the instance method. No? So the method is inside the class itself, no, or the object itself. All right. So moving on to the two other code pieces that we have for models. We have the abilities. No? Abilities are a way to group together model functions and spin them off to separate files. No? For example, this is a bit long code, and really sorry. No? So for example, we have the search functionality. No? For example, earlier, right? Search products. No? For search products, this is our handler. No? We want to be able to find the product. No? For example, we search, for example, crispy barbecue junk food. No? So we want to be able to know all the crispy barbecue junk foods in our e-commerce app. No? So we use .where, no? And inside the product model, no? We have the ability of search product ability that's just inherited. So when it's inherited, no, you can refer to the where class of search product ability directly. No, this product.where is actually belongs in this code, no, because it is a super class, it's inherited. No. But we're using inheritance in a twisted way. No, we're not inheriting that product has different kinds or hierarchy. No. We're using them as abilities, no, to expand our product model. No. So imagine if you don't use abilities, all of this code will be inside product class. No, and we don't want that because our product file will blow up maybe to 1,000 lines or more. No? So that's why we're using abilities to separate, no, groups of related functionality, no, for product For example, we have search products ability, we have check stocking ability, many abilities that the products can do. You can just inherit and will be able to use it. One good advantage of that is, for example, you have search products ability. Maybe you also have a blog, then you can search through the blogs. Maybe you find a similar pattern on how you're doing search products ability and search blogs ability. Then eventually you can decide to make it just a searchable ability. So you just inherit searchable ability to product and to blog. And Viola, you have a generalized ability that you can inherit to multiple classes. And that's the beauty of abilities. You can easily find related code or code that is very similar. So yeah, that's abilities. So tracing this, so we have the product.where, and then the product.where is actually inherited from search products abilities, where all the search products related functionality is like stored or stored away. So that's why our product.py file is like 9 lines only. That's why it's very neat trick in terms of compressing your product models. Next is strategy. Strategy is actually a neat way to organize code if you have two different types of subtypes of models. So for example, you have fish and crisps and chips. So you want that maybe fish has a different kind of packing strategy. Fish is actually a wet market goods. So maybe when you're packing it for delivery, you have to flash freeze it, vacuum pack, insert to cooler, insert to box, send to customer. Whereas junk food or chips, you just insert to the box and send to the customer. So what you do there is just you just pass the strategy, and then the strategy will be the packing strategy. It will be put itself that packing strategy. So when you're ready to pack your fish, you just do fish that pack item, then we'll just refer to the packing strategy, and then it will run the pack for delivery. So the beauty of that is you get to separate between subtypes. Some people will argue that maybe you just put wet product, and then inherits from product. To be honest, I hate inheritance. When you do inheritance, it's very limited. Because if you do strategy, what if you have a different type of goods altogether? For example, the fish. Maybe it's perishable. So you have a different type. So you need a different strategy for that. It's easy to do. You just expand. You just put another strategy here. For example, you do longevity strategy, or storage longevity strategy. Then longevity strategy equals longevity strategy. And then you can do the same pattern with this. So you can expand the different types of your products based on the strategies that you pass along. That's the neat trick with this. Whereas if you just have a wet market food or wet market inherits from product, it's very limiting. You have a lot of duplicated code because of that. So we don't want to do that. So yeah, that's essentially strategies.
Hey, Jambi, I have a couple questions if you're ready.
Yeah. Actually, just a few slides, then we'll reach the end. So.
All right, sounds good.
All right. So next we have gateways. The last piece of our HMG pattern. So for this, gateways are like your applications way of communicating with the outside world. Ideally, all low-level SDKs are stored here, and we just expose convenient interfaces. For example, query by partition key. That's a convenient interface. But you don't want to know every time you're going to query by partition key. You don't want to know all of this. You have to do the syntax of both of three. You have to initialize table, class. You don't want to know that. But if you're using that in the model, for example, this one, DynamoDB gateway that query by partition key. You just need table name, partition key, and ID. That's it. It makes it very simple to access third-party applications because you have gateways that you just have to expose. It just needs three parameters or 3 arguments, and that's it. You don't need to know how both of three works. So that's how we get away with in our team, where some of my developers don't actually know how to use both of three. What they know how to use is my gateway syntax, my gateway libraries. We created a lot of these gateway libraries, maybe 15. We hope to publish them soon in open source. But we have 15 of these. We have SES, we have ECS. Sorry, there's a lot of acronyms there. We have S3 gateway, we have we call this RDS gateway, etc. So a lot of those gateways, they just look at how the gateway is constructed. And they don't have to learn both of three. So it's a great way to scale your team. So you limit what they need to know for the job. Just expose convenient interfaces for communicating with third-party applications. So with this layer taken care of, they just focus on the model, the business logic, and the handler. They just do the model and the handler. They don't need to touch the gateway anymore. Ideally, if you do it right. We also have gateway classes for HTTP requests, Elasticsearch, searches, and readies. So yeah, putting it all together, all of the things I said in the talk, we have the checkout and the product service. So, for example, we have two lambdas, and the checkout service, it's a separate deployment. That's why it's a separate gray box. So is the products. It's a separate deployment as well. But as you can see, they have a lot of shared code, that they use. So we deploy that separately into a Lambda layer, and then they just reference that Lambda layer, so they can refer to the common code that you're building. So let's walk through the journey of the request now. Bear with me. So for example, we have checkout. Let's do products. That's simpler. So we have a get product by ID. So for example, you click on Amazon and you want to search some nail cutters, nail trimmers. So you just put the ID of that, maybe 1, 2, 3, 4. And then as with the syntax we saw earlier, we just use the model to find that entry in DynamoDB. So since we have the ability, the base DynamoDB data model ability, we just use the DynamoDB gateway to essentially find that item in DynamoDB, right? Then we check its stocks, which is the ability. It's also in the shared layer, And maybe we're searching. If you're searching for a product, you can use the product search ability. It's in here because you don't checkout doesn't need it. It doesn't need to share the product search. So you can store it just in the products when you don't need to share it. Also, if you can notice the dependencies, it's different. This one needs both of three Redis and Elasticsearch. This one, Shopify and requests. So this will have a smaller deployment package, rather than in a monolith where all of these five packages you'd have to put inside. You have to put inside your app, making your app deployments huge. So essentially, for this, we are able to store some of our code in a shared layer. I do recommend all handlers and all models should be inside the service. If you notice, we have two products. It's okay. It's okay to duplicate the products, but if you have abilities that you share, for example, this product, you need to be able to have a DynamoDB data model and stock checker. You need to be able to put that in the shared layer. Just inherit it. But if you don't need to inherit it, just put it in your own service, which is the product service. So yeah, there you don't need to inherit. So you don't put the model inside the shared layer. That's a recipe for disaster. You just inherit abilities that's common to both copies of product. In terms of gateway, put all of your gateways in the shared layer. In terms of helpers, put all your helpers in the shared layer. You might need them. In terms of ability, it's your discretion if you want to put abilities in checkout or in just products. So yeah, that's it. So putting it all together, I think this is a bit complicated, but if you go into the hands-on and follow this tutorial and the GitHub repository that I will share with you, you'll be able to map this all out and it will all make sense as well. So yeah, thank you for your time. So let's keep in touch. You can contact me at Raphael Jambalos. Let me turn on my video for this. I wanna see you all, guys. Hello. So yeah, can you see me, Joseph?
Yeah, we got you and we can hear you.
All right. So thank you everyone for your time. Let's keep in touch at raphael.jambalos@gmail.com and dev.pro/Raphael_Jambalos. You can also reach out to me via LinkedIn and reach me via conference in Slack. So I'll also be in the face-to-face. I'll be face-to-face for the 15-minute session. And we also have a Q&A in this part.
Sounds good. And do you want to go ahead and answer those two questions now?
Yeah, let's go.
All right. First one we have is where does configuration live? Is this typically represented in the YAML deployment files?
It's typically in the serverless.yaml. So what we do is we have three types. First is the hard-coded environment variable. We just put it there. If it's not, we don't need to make it unique. Then the second one is the end file. So if you need to put it in an environment file, so you can alter it between environments. And third is the parameter store. If you need to keep it secret between, if you have production database credentials, you can put it into parameter store. That's how we manage our configuration. But how we share it across services, we have a config.yaml that we just inherit to the different serverless.yaml. So we have like config.yaml in the top repository. Actually, I'll show you that. So for example, this one. So we have something like a config.yaml here. And then the config.yaml gets inherited to the, for example, checkouts. And then the serverless.yaml, it refers to the config.yaml that's in the top directory. And the same goes with the products. It inherits the config.yaml in the top directory. So that's how we share it. So I answered it two ways, how to share it and how to manage configuration. That's my answer. Joseph, have any questions?
All right, yeah, we got one more. Any thoughts on converting existing applications like a Django app into something like this? It seems like to use this pattern, you need to design for it from the beginning.
Absolutely. So if you want to take advantage of the cloud native approach, you really have to design it from the very beginning. So what I recommend is a phased approach. First, you do deploy your applications in Lambda Monolith. So you get everything in Lambda first. Once that's done, once that's possible already, you'll be able to split off chunks of your monolith into like cloud native small services. As you improve them, for example, you need to improve your product catalog. Maybe remove that chunk from the monolith and put it into a microservice. So you'll be able to design in the best practice.
All right. Looks like we may have one more. They say that AWS costs are always confusing. How much can be the monthly cost associated for a simple API using AWS Lambda?
When it's a POC level, it's usually free. But it depends. If you have a mature application, a lot of customers keep using it. If a lot of customers keep using it, it will magnify mistakes that you may be doing. For example, we have this. We call DynamoDB a lot of times during our request. So we ended up calling it 300, 400 times every time we display the home page. So imagine all of our 10,000 customers calling DynamoDB 300 times. So it magnifies the mistake. So you won't see it when you deploy. Not like when you deploy for example, your Django app. You deploy it in EC2. You don't want to be, like, for example, you don't want to be limited. You don't, when there's, like, you over provision the EC2. That's why the cost is upfront. Whereas if you're in serverless, the cost always depends to how much your application gets used. So if you design it poorly, if you have 10,000 users calling it all at once, it will magnify those mistakes, and it will cost maybe $1,000 but still cheaper. Around 200. The largest bill that I saw is like 2,000 USD to 5 USD on a full serverless setup, no? And that's with a lot of mistakes along the road, no? And a lot of some easy to set up. So yeah, it's the short answer is it depends on usage.